Day grade 10s, 11 and 12s, welcome to this session on functions where we'll be focusing on how to interpret graphs. Okay, most of the time learners lose marks unnecessarily because they do not know how to interpret graphs. So this session is on graph interpretation, and I'm going to take you through some few notes as well as examples. Then we go to exam past papers. Okay, so the first thing that we're going to look at is, let us talk about the length of vertical as well as horizontal lines, okay, which are found between two functions. For an example, let us say I'm giving you the function f, which is a parabola, and function g, which is a straight line, okay. Then between them, there is a vertical line AB, all right. So if I were to ask you to find the length of AB given the value of x, okay, or represent the length of AB in terms of x, how would you find the length of AB? All right, so the formula will be the length of AB will be equals to, remember, we said we are dealing with the vertical, so that means we must look at the y values. Okay, so it's going to be the y value at the top minus the y value at the bottom. So of course, which y value is at the top? The y value of A, and the one that is at the bottom is the y value of B. So it's going to be the y value of A minus the y value of B, which also you can say the function that is at the top is your f at x, and the function that is at the bottom is your g at x. So you can say f of x minus g of x, okay, or memorize it as y top minus y bottom. Okay, that is how we would find a length of a vertical line found between two functions. All right, then also if I gave you two linear functions, the first one being this one, then the second one being this one, then between them they are connected by a horizontal line which is parallel to the x-axis. Okay, then I ask you to find the length of line CD. How would you find it? Remember, now we are dealing with a horizontal line. Okay, when we were finding the length of AB, we were looking at the vertical. Okay, so in this case we are not dealing with a vertical line, but we are dealing with a horizontal line. How would you find the length of a horizontal line, okay, which is parallel to the x-axis, or a horizontal line that connects two functions? Okay, so it's gonna be CD, which is the length of CD, equals to the x value to the right minus the x value on the left. Okay, so that means it will be the x value of D, which is on the right, minus the x value of C, which is on the left, and that will give us the length of CD. Okay, which makes sense because let us say the x value of D here was 3, and then the x value of C here was a minus 2. So it means the length of CD would be 3 minus 2, which will be 3 plus 2, and it will be 5 units. Remember, length is always positive. Okay, so these formulas have been written in such a way that they will always give you positive answers where we're calculating length. All right, so CD in a way will be calculated by saying the x value of D minus the x value of C, and that will be giving us the length of line CD here. Okay, very important. Now I want us to go through an example. We are told that line AB below can move anywhere between points C and D. Okay, so line AB here is a vertical line. Okay, meaning if I am to find the length of AB, I'll say y top minus y bottom, which will be the y coordinate of A minus the y coordinate of B, or g of x, which is a straight line, minus f of x, which is a parabola. Okay, so let us finish the question. It is given that f is 2x squared minus 8x plus 6, and g is equals to minus 2x plus 6. Okay, we are given the equations of the linear function and the parabola. Write down an expression, okay, an expression for the length of AB in terms of x. Hence, determine the length of AB when x is equals to 2. So here we are given two questions at once. First, you must find the expression of AB, then find the length of AB when x is equals to 2. Okay, so I think I've already said it. We said the length of AB will be y top minus y bottom, which is the function at the top minus the function at the bottom. That is your g of x minus f of x. So g of x was minus 2x plus 6. Then your f of x was a 2x squared minus 8x plus 6. So when we subtract them, we end up with AB being equals to minus 2x squared plus 6. Okay, please take note, I've already distributed the negative sign here. Then we collect like terms. So minus 2x squared plus 6 will be the expression for the length of AB in terms of x. But remember, we're given that x is equals to 2. So to find the length of AB, I'll substitute 2 wherever there is x. Okay, and then when I substitute 2, I'm getting my length of AB to be equals to 4. But remember, length is length must have units. Okay, and length is always positive. So AB is equals to 4. Don't just say 4. It is 4 units. If you knew the units, other units that were given here, would say AB equals to 4 meters or 4 centimeters, etc. Okay, so where we are not given units, we'll just say units. Okay, very important. Now, let us go to notation. In functions, we usually engage with the inequalities that we have covered in term 1, grade 11, as well as grade 12, and also grade 10. We did inequalities in term 1, algebra. So let us look at the notations, although we have covered them in class, but very important for me to remind you. Okay, so what is the meaning of this notation here? Okay, remember this part here means less than, and then this part here means equals to. Okay, so how do we say it verbally? This is less than or equals to. Okay, and when we use our brackets, we use the square brackets, the ones that look like this. Okay, because of this sign here means the value is included. Okay, the critical value is included, and most of the time we would represent a value that is included with a shaded dot. Okay, then also this one here means greater than or equals to. Okay, which also takes the same brackets, which means included. The value will be included whenever we write those brackets, and when we draw a number line, we will be using this shaded circle. Okay, very important. And then let us talk about this. This will be your less than, and this will be your greater than. Okay, less than means smaller than, then greater than means bigger than. Then whenever we use these two symbols here, the brackets that we'll always use are the open brackets. Okay, and what do they mean? They mean that the value is not included. Okay, and then on a number line, this means we will be using our open circle. Okay, or a circle that is not shaded. Okay, having said that, let us now go through very important notes, how to read from the graph. Okay, because most learners, they can answer questions where they need to calculate algebraically, but where now there is a graph that must be interpreted, they lose marks. So most of the time you'll be required to answer questions that will say for which values of x will. Okay, so we've got a lot of cases, but I've tried to at least look at most of the questions that will come, that you will be exposed to in an exam, and I want you to master them. Okay, math is very easy. Now, let us start with the first one. They will say for each values of x. Well, if I given a function f, they will say, well, f of x be greater than 0. Okay, now let's talk about greater than 0. Any number that is greater than 0 is positive. Okay, that's the first thing. And remember, f of x, we once said it is the same as y. So it means we are saying to you, we are looking for where the function will have all positive y values. Okay, and obviously all y positive values will be above the x-axis. Okay, so you will read where your graph is starting to be above the x-axis. Remember, your critical values cannot be included because at the critical values, that's where the function is equals to 0. That's where the y values are equals to 0. So where the function is equals to 0, the values there are neither positive nor negative. Okay, so and what we're saying there is the function is actually equals to its x-intercepts. Okay, so we are looking for where the function will be above the x-axis. So we cannot include the critical values in this case. So I've explained we are looking for where f is positive, and this means f will be positive where it is above the x-axis. Okay, so you'll be telling me those x values. And then second one, it is the opposite of the first one. We are looking for where f is less than 0, meaning we are looking for where the function will be having negative y values, where f is below the x-axis. Okay, because below the x-axis, all y values are negative. Okay, so we are looking for where f is negative, meaning where we get negative y values, and that is below the x-axis. Okay, so you'll be giving me those x values which satisfies this case. And then we've got the third case, which usually is most examinable, and most of the time learners get 0 marks for this part here. And it's very easy. Okay, remember, first of all, this is x. It represents any x value. This is y, although it's written as f of x, but it is y. Okay, so what we're saying is, remember, this means greater than 0 means where we get a positive. So what we're saying to you is we are looking for where we multiply an x value and a y value and we get a positive. Remember, then in this case, it means you are going to have two options. The x and the y value must both be positive or must both be negative for us to get where the values of x and y will multiply to give us a positive. Okay, remember, if x and y are both positive, positive multiplied by a positive, okay, that will be a positive, or negative times a negative, that will be a positive. Okay, so we are looking for where x and y are both positive or negative values, such that when they multiply we get a positive outcome. Okay, now let's go to the fourth one. Okay, before you go to the fourth one, I think I've already explained. We're looking for where negative x value multiplies with a negative y value to give a positive result or outcome. Okay, I've already explained this one. Now the fourth one, this is when you are given two functions at the same time. Say you are given a linear function and the parabola. So we just say for which values of x will the y values of the two functions multiply and they give us a positive. Of course, this is when the negative y values of f and negative y values of g, or positive y values of f and positive y values of g multiply. Okay, so the values, the y values of f and g must be both positive or be both negative for us to get a positive outcome. Okay, so you'll be looking at where are the two functions having both negative or positive y values, and in that regard it means the x values that give us this condition will be the solutions. Okay, very important. Now let us go to number 5. With number 5, we are saying this is the opposite of what we've just spoken about. We are looking for where, now in this case, be very careful. Okay, we are looking for where f and g, the two functions, the y values of the two functions multiply and we get a negative. What does that mean? It means the y values of f, if they are positive, the y values of g must be negative. Or if the y values of f are negative, the y values of g must be positive. Because when we multiply different signs, then we will get a negative. Okay, so most of the time this happens when one function is above the x-axis and the other one is below the x-axis, because they will be having different y values. Okay, such that when you multiply the y values, then they give you a negative. And in that case, it means the x values which fall within that boundary, they will be our solution. Okay, very, very important. Now, let us go to the sixth case. The sixth case is the same as multiplication. Okay, so here, for us, remember this means greater than or equals to 0. Okay, so it means our critical values will be included, but also we are saying where will f and g divide such that you get a positive, and the critical values will be included. So when we look into this problem, remember, for us to get a positive, f and g must both be positive. Okay, because a positive divided by a positive, we get a positive. Or both f and g must be negative, because a negative divided by a negative, then we are getting a positive. Okay, so we just saying this case here and the previous case that we've just looked at now. Okay, this case here, they are somewhat similar, because remember, division and multiplication, they are really doing the same thing. Okay, don't forget, in this case, because it is greater or equal to 0, the critical values will be included. Okay, and we call them CVs. All right, and then number 7. Okay, so with number 7, I think we are clear as to what is happening here. Greater than or equals to 0 means, remember, greater than means we are looking for where the function h will be positive. That is when it has positive y values. Okay, and that is when it is above the x-axis. That's number 1. Number 2, we are saying whatever critical values that we have in this case, especially when you draw a number line, then those critical values will be included. Okay, so we are looking for where h is positive, which is above the x-axis, and the critical values which assisted us to draw a number line will be included. Okay, and then I think g of x less than or equals to 0 will be the opposite of h. Okay, in this case, so we are looking for where g will be a negative function. That means where will g be below the x-axis? Because if it's below the x-axis, all y values of g will be a negative, and it means then we'll check which x values fall within this condition. Okay, and don't forget, in this case, it means equals to means the critical values will also be included. All right, now next up we've got g of x equals to f of x equals to 0. I usually say if it's equals to 0, please start by transposing one of the two functions such that you have one function equals to the other function. So first, as I indicated, I started by transposing negative f of x. Okay, so when I take negative f of x to this side, it becomes positive f of x, and it means I'm looking for the values of x where f and g will be equal. Okay, so remember, they are equal where they intersect, where they cross. Okay, I've written it here, where they are intersecting or where they are crossing. You wouldn't have understood this question if you didn't start by transposing. But after transposing, you are able to see that you are looking for where g and f are equal. So where will they be equal? They will be equal where they are intersecting. Okay, very important. Now let's go to the second last problem. So with this problem here, f of x greater than g of x. This is very simple. Okay, first of all, critical values are not included, but what is the meaning of this? Remember, f greater than g. What does that mean? It means f bigger than g, f on top of g. Okay, so we are looking for values of x where f will be above the function g. Okay, and also if we now twist it, this is the same thing. We are looking for where the function g will be above the function f. So you're going to look at the x values where the one function is above the other function, and that would be your solution. Okay. Having said that, we may also get this case here, the last case where g of x, h of x, k of x, f of x, whatever, is equals to 0. So what is the meaning? Remember, g of x represents y. So where will y be equals to 0? Okay, y will be equals to 0 on the x-axis. You agree with me? So it means you'll be saying g of x is equals to 0 at my x-intercepts. Okay, remember when we are finding our x-intercepts, we say let y be equals to 0. So when I say for each values of x, will g of x be equals to 0, it is the same as I'm asking you to write down the x-intercept of the function g. Okay, very, very important. Now, let us go to the first exam problem and try to check how far we are with our understanding. I'm pleading you guys, do watch the session on translation and transformation where we were talking about reflection as well as our shifting of the graphs, okay, before you can attempt this question here. So I'm going to do it assuming that you have looked at the video. If you haven't, start there and then come back later on this question. Now consider the function f of x equals to 3 over x minus 1 minus 2. There is another video which I'm covering hyperbola alone, and I'm also going to ask you to please watch it, okay, where I'm discussing hyperbola in detail. So 3, remember, that's where we wrote a in the other session, and we said it determines whether the two-piece function will be on which quadrant. The quadrants that we are talking about are given by the asymptotes. Okay, so since 3 is positive, it means our function f will be on the first and the third quadrant of the asymptotes created by the asymptotes. Then x minus 1 equals to 0, x equals to 1 will be our vertical asymptote right here, and then y equals to a minus 2 here will be our horizontal asymptote. Okay, then we can find our intercepts by letting x equals to 0, that's when we are finding the y-intercept, or letting y equals to 0, that's when we are finding our x-intercept. Okay, now let us start. A, write down the equations of the asymptotes of f. They are saying write down the equations, underline. So if you just say to me, answer for A is minus 2, answer for the vertical asymptote is minus 1, I'm going to mark it wrong, okay? Because that is not an equation. An equation will have x equals 2 and y equals 2. Those are equations, okay? So for A, I answered the question by saying the horizontal asymptote will be y equals to a minus 2 and the vertical asymptote will be x equals to 1. Okay, let's go to B. Calculate the intercepts of the graph of f with the axis. The intercepts. So they want you to find the x and y intercepts. So I'm going to start by the y-intercept and let x be 0, meaning where there is x, put a 0. So I've put a 0 there, and I've also put a 0 here, f of x. So my y-intercept will be a minus 5. Okay, so it will be f at 0 equals to minus 5, and the coordinates of the y-intercept will be 0 is to minus 5. Then the x-intercept, let y be 0, so there is a 0 there. Then start by transposing the minus 2 to this side, okay, and then cross multiply. So once I've done that, I've transposed my 2 to the other side. Remember, the 2 will be over 1, okay. Then you start cross multiplying. 2 times x will be a 2x, minus 1 times 2 is a minus 2, and then 3 times the over 1 will be a 3. Solving for x, I found that my answer is a 5 over 2. So the coordinates will be 5 over 2 is to 0. Okay, very important. Now, let us go to the next question. The next question is on sketching a graph. Sketch the graph of f. Okay, This is question C. So we said the function is a hyperbola. So when we sketch it, we must start by putting in the asymptotes. There's the vertical asymptote there. Okay, let me use a different color. There's the vertical asymptote there. Okay, and then you must label it x equals to 1. There is the horizontal asymptote there. Then you must also label it. Okay. Then there is my x-intercept there. You must also label it. And there is my y-intercept there. And you must also label it. Okay. So my y-intercept here, I'll just write it here, will be 0 is to minus 5. Okay. And then you now put in your 2 pieces for the function, which will be this piece here as well as this piece here. And indeed, they are found in the first quadrant as well as the third quadrant of the asymptotes. Okay, of the asymptotes. Well done. Now, let us go to the next question, D. Write down the range and domain of f. Okay, let us start with the domain, looking at the function. So remember, where is the function of f starting? It is starting from negative infinity, and then it will end somewhere there, we don't know where, okay, which is positive infinity. But don't forget, when the function comes from negative infinity, at x equals to 1, it's breaking, okay? It's not defined at x equals to 1. And also, it starts at x equals to 1 from here, going all the way to the right. So we must take note of that. We cannot include a 1 because x equals to 1 is undefined for this function, okay? So my domain will then be x an element of from negative infinity up to 1, then from 1 again up to positive infinity. If you don't like this style of writing, then you can say we consider all values less than a 1 and all values which are bigger than 1 but not including 1, okay? Then let's go to the range. When you look at the range, the function is starting from a negative infinity also, and it is ending at a positive infinity. But take note, the graph or the function doesn't pass through the line y equals to 2, the asymptote, okay? So you must take note of that. So it is starting from negative infinity up to y minus 2, which is not included. Then also start from y minus 2 here, and goes all the way up to positive infinity, okay? So this will be y is an element of minus infinity is to minus 2, okay? Very, very important. And then also, it will be from minus 2, okay? This is a mistake here. This is from minus 2, from minus 2 up to positive infinity, okay? Very, very important. If you don't like that style of writing, then it will be y less than minus 2 or y greater than 2. Okay, good. Now let us come to question C. Oh, question E. Write down the range of y equals to minus f of x. Now I want you to take note of this. Minus f of x. The negative comes from reflection along the x-axis. So all the y values will change. Okay. So it means I can just multiply the range of f by a negative and I'll be getting the new range. Okay. Please check your translation and transformation lesson. Okay. So it means my answer to E will be, remember, I said f is reflected about the x-axis. That's why y changes. So since our original horizontal asymptote was y equals to a minus 2, then it means it will also change and become y equals to 2. Okay? Because all the y values for this function will change about the reflection of x-axis. Okay? So as a result, it means then my asymptote will become y equals to to 2. The new horizontal asymptote. Therefore, the range will then be y is an element of, remember now, the function will start from negative infinity up to 2, and then we'll start from 2 up to positive infinity. Okay, very, very important. Now, let us go to f. Write down the range of y equals to 2 times f of x. So what is happening here? We are multiplying all values of y by 2. But remember, when we are dealing with our exponential function or the hyperbolic function, and we have to talk about range or the domain, only the horizontal asymptote or the horizontal asymptote and the vertical asymptotes matter in this case in order for us to get our domain and range. Okay, so since all y values are multiplied by 2, that means in this case where I'm going to talk about the range, the horizontal asymptote will be the one that is affected. Okay, and I'm looking at range, that means my horizontal asymptote will be multiplied by a 2. Okay, so let us quickly go there. This is what is going to happen. Okay, so y equals to 2 times f of x. The original horizontal asymptote was y equals to a minus 2. But since all y values are multiplied by 2, the horizontal asymptote must also be multiplied by a 2. So minus 2 times 2, then we get a minus 4. Okay, therefore, the range will then be from negative infinity. Remember, it was up to minus 2, but now it will be up to minus 4, which is not included because it's a asymptote. And then from minus 4 up to positive infinity. Okay, very, very important. Now let us go to G. Write down the domain of y equals to f of minus x. Remember, where does the minus x come from? It means there was a reflection along the y-axis. Hence, there is a change in the x values. Okay, so I'm going to multiply all the x values of f by a negative and then write down the domain. So that means since the original vertical asymptote was x equals to 1, then it means after the reflection along the y-axis, the x value of the vertical asymptote will also change from being x equals to 1 to being x equals to a minus 1. You agree with me? So that means for G, which is a reflection along the y-axis, we will be getting the new vertical asymptote, which will be a minus 1, and therefore our domain will be from negative infinity up to the minus 1, then from minus 1 up to positive infinity. You agree with me? Very, very important. And then now let us go to H. Okay, question H, write down the domain of y equals to f of 3x. So f of 3x, what does it mean? It means all the x values have been multiplied by 3. You agree with me? And since I'm writing the domain, it means also my vertical asymptote will be multiplied by 3. So originally it was x equals to 1, and therefore now it's going to be x equals to a 3. You agree with me? So let us check. That is our G. That is H. Okay. So our new vertical asymptote, remember now, where it was x minus 1 equals to 0, but now we are going to substitute by 3x where there was x, and then solve for x. So when I solve for x, my vertical asymptote, the new one, is 1 over 3. And then this means that my function f at 3x, okay, will then have the domain starting from negative infinity up to 1 over 3, and then 1 over 3 up to positive infinity. All right, very, very important. So where there was x, I've actually put 3x, then I solve for x, which is my vertical asymptote, the new one, and then I wrote down the domain. Okay, only the vertical or the horizontal asymptotes are changing. Please take note of that. And then next up, we've got another question, which is the last question. Write down the range and the domain of k of x if k of x is f at x minus 3 minus 2. Now I want you to notice something. Okay, there is a shifting, there is a translation on the values of x, and x minus 3 is a shift 3 units to the right. Okay, but also there is another shift downwards by 2 units. So it means both the domain and range of the original function of f will be affected. Okay, so the vertical asymptote will shift by 3 units to the right, and then the horizontal asymptote will then shift by 2 units downwards. Okay, very important. Now let's go to the answering of the question. So k of x equals to f at x minus 3 all minus 2. So the domain of f, remember, was x equals to 1. But now since the graph of f shifted 3 units to the right, it means the new vertical asymptote will be x equals to 1 plus 3, because 3 units to the right. So the new vertical asymptote will be x equals to 4. Okay, it will be x equals to 4. That means then my domain will be from negative infinity up to 4, and from 4 up to positive infinity. You agree with me? And what about the range? The range originally, okay, was y equals to a minus 2, if you remember. But remember now the shifting here means we have shifted all y values of f by 2 units downwards, including the horizontal asymptote. So from being a minus 2, then we're going to say y equals to minus 2 minus 2, and we are getting a minus 4. Okay, so as a result, my range will then be from negative infinity up to minus 4, and from minus 4 up to positive infinity. Okay, so well done. We have covered that question, and now we want to look at the next question. The sketch below shows the graph of f. Okay, so this is your f, which is a parabola, and g, which is a straight line. Okay, now 5.1, determine the coordinates of a. So we notice that a is the x-intercept of f, so you're going to let y be equals to 0, then we solve for x. Okay, so a is the x-intercept, so x-intercept, let f of x be equals to 0, or let y be equals to 0. So there we go. Then x equals to 0, or x equals to a minus 3. Okay, but remember x equals to 0 is at the origin when you look at this particular graph. So a can only be minus 3 is to 0. Okay, now let's go to 5.2. Calculate the coordinates of p. Okay, there is p, which is the turning point of f. Okay, since I know my a x value and I know my o x value, this will act as the midpoint. Okay, because the distance from a to p and from p to o will be equidistant. So what am I going to do? I'm going to use my midpoint formula as method number 1, and that will be the x coordinate of p, which is the midpoint, is equals to the sum of the x coordinates of a and o, and divided by 2. Then by substitution, the x value of the midpoint p is minus 3 over 2. So for me to find y, which is the y coordinate of the turning point, I must substitute the value of x for p into the original function f. So when I substituted it back, I got minus 9 over 4. Okay, that means the coordinates of p will be a minus 3 over 2 is to negative 9 over 4. Okay, alternatively, you can just use the equation of the axis of symmetry, where you will be finding the x value of the turning point using this formula here. Okay, please watch the other sessions where we cover these things. X equals to minus b over 2a. Then you first need to write it in standard form to c or b. So this became minus 3 over 2, which is the same answer. Then we substituted back into the original function of f, and we got the answer as a minus 9 over 4. Okay, this is our answer. Therefore, the coordinates of p will be minus 3 over 2, is to negative 9 over 4. Okay, then next up, we have another method, okay, but it's up to you which method you want to consider. They are more or less the same. It's up to you which one you favor, okay. The next method is on completing the square. So I first rewrote x times x plus 3 in standard form, and it was x squared plus 3x. Then next up, I completed the square, okay. So when you complete the square, you're going to add and subtract half of the value of b squared, and then you complete the square, okay. So then my answer became f of x equals to x plus 3 over 2 all squared minus 9 over 4, where minus 3 over 2 and the minus 9 over 4 were the points of P, which is the turning point, okay. If you are doing grade 12, we can also do our derivatives, okay. We can derive the function f. Finding the first derivative of f, we are getting 2x plus 3. Then let f derivative of x be equals to 0, then solve for x. Then we found that our x was equals to minus 3 over 2. Substitute into the original equation, then we find the same answer, minus 9 over 4. Then we got the coordinates of P. Okay, well done. Now let us come here. Determine the average gradient of f between x minus 5 and y minus 3. So since we know that the x values are minus 5 and minus 3 respectively, we need to know their y values by substituting minus 5 and minus 3 into the original equation. Okay, so that's where I'm going to start. So I'm going to start by finding the y values. When x is minus 5, I found that my y value is 10. When x is minus 3, I found that my y value is minus 3. Then we have coordinates now. We can use our y2 minus y1 over x2 minus x1 formula to find the gradient. Then my answer became a minus 5. Okay. Now next up, 5.4. Determine the values of x for which, remember, f of x greater than 0, meaning where f is positive above the x-axis. Okay. So f is positive here and also positive here. That's where the graph is above the x-axis. Okay. Remember, this will be from infinity, negative infinity this side up to this value here, which is minus 3 but not included. Then from 0 not included up to positive infinity. Okay, so those will be the x values for which f will be greater than 0. So let's write it down. So in writing, we were saying, okay, we were just saying we are looking for where f is positive. Okay, so it's positive from negative infinity up to minus 3 and from 0 up to positive infinity. Okay, very important. Now let us go to 5.5. Now in 5.5, we are required to determine the coordinates of the turning point of h. Okay, but you are given that if h of x is equals to x minus 2, this means on the function f, I have shifted f 2 units to the right. Okay, and for me to find the coordinates of the turning point of h, only the x turning point of f is affected. So I'm going to say plus 2 on the x value of the turning point of f. Okay, the previous one. But the y coordinate of f will remain the same, which will be the same for the coordinate y coordinate of h. Okay, so let's do 5.5. Very easy. So what is happening here is that the turning point of f was minus 3 over 2 minus 9 over 4. Then when the graph was shifted 2 units to the right, it means I'm going to add plus 2 on minus 3 over 2, and my answer becomes a positive half. Okay, becomes a positive half. But remember, what did I say about the y values? They remain the same because the movement was along the horizontal, so y doesn't change. Okay, then next up, we're going to look at 5.6. L is a point on the straight line, and we see it. And M is a point on the parabola, and we see it. And from M to L, there is a straight vertical line which is perpendicular to the x-axis, so that the length of LM can be written as this thing here. Okay, so first of all, L is at the top, M is at the bottom, so it's going to be y top minus y bottom, which is the function of G minus the function of F. Do you agree with me? So once you have done that, there we are. Y top minus y bottom, meaning G of x minus F of x. Then by substitution of the equations, my standard form for the equation was minus x squared minus 7 over 2x plus 2. Okay, but then remember they said I must write it in the turning point form. So I'm going to complete the square by first factoring out the negative, and then I'm here. Then you're going to add and subtract the half of 7 over 2. Okay, so that will be, okay, we are now here. That will be negative times x plus 7 over 4 all squared minus 49 over 16 minus 2. Okay, then the final answer then is LM equals to negative x plus 7 over 4 all squared plus 81. Okay, so this plus 81 over 16, you'll get it when you punch in your calculator. Minus 49 over 16 minus 2. Okay, then you multiply by a negative. When you distribute it, then you'll get the same answer. Okay, very, very important. Last question is on implicit information. You are given information and you need to know how to make use of the information that is provided to you without any form of calculations. There will be a question in the exam which looks like this one. Sketch the graph of f, and we see k over x plus p plus q. This must be a hyperbola. But we are told that if the domain is given as, remember when we are writing the domain of a hyperbola, we must take note of the vertical asymptote. So the domain is given as x element of real numbers, but x cannot be minus 1. That means what? That means that x cannot be equals to minus 1 is undefined. Okay, that makes x equals to minus 1 our vertical asymptote. Also, they're saying the range is given as y element of real numbers, but y cannot be 2. So since y cannot be 2, it means the function is not defined at y equals to 2, and that will make y equals to 2 our horizontal asymptote. Okay, so I've got two things now. I've got p, I've got q, and I need k. But what did they tell me? They said here, they said k is less than 0, meaning k is a negative. Remember, we said the value of k here will tell us what? It will tell us where the two-piece function will lie, in the second and the fourth quadrant, okay, or in the first and the third quadrant. So if it's negative, okay, then it means we are in the second and fourth quadrant. Okay, very, very important. And then we are given the x and the y intercept. Now let us sketch. Okay, I think the question said you must sketch. So I've sketched. There is my graph on the second quadrant as well as on the fourth quadrant of the asymptotes. And then there's the x-intercept there, and there's the y-intercept there. And the horizontal asymptotes are also labeled. Please make sure they are also labeled. If you didn't label it, please start now and label your asymptotes. We have come to the end of the session. Thank you for watching. Please also watch other sessions on functions, okay? And then also do as many past papers on this topic functions as possible, because this is a very easy topic. All right, so also please practice a lot. The only way you can know math is to do math. Okay, please don't forget to subscribe on the live sessions that I keep on posting on YouTube. Very, very important. Thank you very much and keep well. I wish you all the best with your mathematics, and I know you can do this. Sharp.